Lesson: Vertical asymptotes and table of values and signs. X-intercepts and table of values and signs. For rational functions. You can't ever reach perfection, but you can believe in an asymptote towards which you are ceaselessly striving. Paul Kalanithi. If a rational function f is defined on the set of real numbers minus the set made of k, then the function either has a vertical asymptote or a hole at x equals k. If x equals k is a vertical asymptote of a rational function, then when x approaches k from the left, y approaches negative infinity, or y approaches positive infinity. If x equals k is a vertical asymptote of a rational function, then when x approaches k from the right, y approaches negative infinity, or y approaches positive infinity. If point P of coordinates kr is a hole of a rational function, then when x approaches k, y approaches r. Use the table of values and signs to describe the behavior of the function in the vicinity of the given values. Question 1. The table of values and signs is given. When x approaches negative 3 from the left, y approaches positive infinity. As x increases in values towards negative 3, y increases without bound towards positive infinity. When y approaches negative 3 from the right, y approaches positive infinity. As x decreases in values greater than negative 3, y increases without bound towards positive infinity. F is increasing on an interval, open interval a negative 3, where a is less than negative 3. Both x and y are increasing. F is decreasing on an interval, open interval negative 3b, where b is greater than negative 3. As x is increasing, y is decreasing. F of 5 is equal to 0. When x approaches 5 from the left, y approaches 0 positive. The graph is above the x-axis and decreases on the interval open a5. When x approaches 5 from the right, y approaches 0 positive. The graph is above the x-axis and increases on the interval open 5b. Here we have the behavior of the function around the vertical asymptote, drawn by these two purple lines, and the behavior around the turning point at x equals 5. It's the behavior of the function around the x-intercept. There is not enough information to finish this sketch. Question 2. The table of values and signs is given. As x approaches negative 4 from the left, y approaches negative infinity. As x increases in values towards -4, y is decreasing without bound. When x approaches -4 from the right, y approaches positive infinity. As x decreases in values towards -4, y increases without bound. This is the behavior of the function around the vertical asymptote x equals -4. F is decreasing on an interval open a -4, a less than -4. As x increases, y decreases. F is decreasing on an interval open -4b, where b is greater than -4. As x increases, y decreases. When x approaches 2 from the left, y approaches positive infinity. As x increases, y increases without a bound towards positive infinity. F is increasing on open A2. As x approaches 2 from the right, y approaches positive infinity. F decreases on open 2b, where b is greater than 2. As x increases, y decreases. This is the behavior of the function around the vertical asymptote x equals -4. This is the behavior of the function around the vertical asymptote x equals 2. But there is not enough information to finish the sketch. In conclusion, if x approaches k from the left and y approaches negative infinity, then f is decreasing on open interval ak. If x approaches k from the right and y approaches negative infinity, then f is increasing on open interval kb. If x approaches k from the left and y approaches positive infinity, then f is increasing on open interval ak. If x approaches k from the right and y approaches positive infinity, then f is decreasing on open interval kb. The end.